This demo showcases AI-driven auto recon system built by extending Anduril's open source sample project. The system uses given set of coordinates and disposition as an input for different machine learning models to determine proximity, assess threat levels, make tactical decisions, and finally calculate movement vectors to position asset for optimal response. Traditionally, we used to generate inferences by passing inputs to black box models which would then generate responses. But now we can seamlessly integrate DeepProve, which accepts the model's Onyx file and some inputs to generate a response that contains model's output and a zero knowledge proof. This integration provides cryptographic guarantees for critical decision-making processes while maintaining operational security, as you can now verify zero knowledge proof instead of blindly trusting the model's output. Here we can see that the config file contains a set of different scenarios. We'll be choosing the first scenario where we have the assets in the track's coordinates along with the track's disposition. I'll start the system in three different terminals. In the first terminal, I'll be starting the main AutoRecon application, which is responsible for ingesting the entities and orchestrating tactical decisions. In the second terminal, I'll be starting the simulated asset, and in the third terminal, I'll be starting the simulated track. You can watch the logs here in the main AutoRecon apps terminal to confirm that the app is analyzing proximity, performing threat assessment, running some tactical decision model, and creating a task for the asset over here. And our simulated asset picks up that task and starts moving to the set of coordinates that are given as a response by this movement calculation model. We can go over to Anduril's UI to see if the asset is actually moving to the AI's chosen coordinates. And here we can see that this asset is slowly moving away from this hostile simulated track. Now let's look at one of the proofs that we have generated using this system. We can see here that we have a ton of different proofs that have been created, but most of them are for the dummy entities that the Anduril system contains. We are mostly interested in our assets proof. So let's open the movement calculation proof for our asset. We can open this and see that the JSON contains the model's output and it is accompanied with a zero knowledge proof. We can use the verify proof binary to actually verify this zero knowledge proof. So I'll provide the proof for the movement calculation, and here it is. So when I run this binary with this particular proof, you can see that the proof is verified successfully. To illustrate any temper resistance, I'll change one of the values over here, and when we run the same command again, we can see that the proof verification has failed. This proves that any malicious or accidental changes are easily detectable and rejected. Thus, the proof integration turns models' outputs into verifiable inferences with minimal friction, which is ideal for defense and maritime edge systems and equally valuable in other regulated industries. While this demo builds on an open source Anduril example and small neural nets, the same approach scales to larger models and different deployment modes with the same core benefit: decisions you can trust because they are provably correct.